In this video, we're going to learn how to find the exact value of expressions involving inverse trigonometric functions. Now, the first thing you're going to notice is we're going to find the exact value of each expression, but they are not inverses of each other. So this isn't sine of sine inverse like in a previous lesson. These are two different trig expressions. So the way we go about solving this is we first look to tangent inverse of 1/2 as an angle, because that's what it would output is an angle. So we're going to think of it as an angle. So now we have sine of theta. But now what is this angle referring to? We either have to find the degree of that angle, or we can use a right triangle to help us solve this. Now, this is tangent inverse of 1/2, meaning since I'm using a positive input, the angle should be somewhere in the first quadrant, referring to some point in this direction. So when I draw a right triangle for me to hopefully solve this, I'm going to draw it with the idea that if this was my x-axis, this side would rotate upwards into an angle in the first quadrant. Because the angle is referring to, now what tangent inverse of 1/2 is referring to is this particular angle here, the rotation to that point. So theta would be that angle. So now that I know what theta is, now using that same statement on the right over there, I can also say that tangent of theta is equal to 1/2. I know tangent as opposite over adjacent. So on my right triangle, I'll put 1 as the opposite side and 2 as the adjacent side. And now I have a right triangle I can solve and figure out sine for. So sine is opposite over hypotenuse. So I need to find out what the hypotenuse is. I can use Pythagorean theorem. So 1 squared plus 2 squared is equal to c squared. So 1 plus 4 is equal to c squared. 5 is equal to c squared. So c is equal to the square root of 5. Also know I'm in the first quadrant, which also lets me know that sine should be a positive value. So as a way of double checking. And sine here would be 1 over the square root of 5, which when rationalized is square root of 5 over 5. So my final answer I could write as sine of tangent inverse of 1/2 is equal to the square root of 5 over 5. So now we do have avenues for evaluating these, even if they aren't perfect inverses of each other. Let's look at the one right below it. Cosine of sine inverse. So now I see that sine is sine inverse of a negative value. Means if I'm looking at theta is equal to sine inverse of negative 1/3. I'm saying that sine of theta is equal to negative 1/3. Which means I'm looking at some angle that's in this fourth quadrant, because sine is negative. And the reason why I'm picking the fourth quadrant rather than the third is sine inverse's output is always an angle from negative pi over 2 to pi over 2. So some angle down here, about a third of the way down, is the angle I'm referring to with this particular problem. So this particular angle I'm going to use for this problem, because again it's cosine. If I replace all that just with a theta, that's the angle I'm referring to. So I'm going to draw my triangle, but I'm going to angle it down into the fourth quadrant as a nice reference along my x-axis, and I can clearly see this should be my angle. And now I can use this statement here, sine of theta is equal to negative 1/3. I know that's opposite over hypotenuse. I'm in the fourth quadrant, so I'll be a negative y, and I'll keep my hypotenuse positive. And now I can use Pythagorean theorem to find the adjacent side so I can finish solving the problem. So that would be -1 squared plus, this I guess would be side b, is equal to 3 squared. So a squared plus b squared equals c squared. Give you 1 plus b squared is equal to 9. B squared is equal to 8. B would be equal to the square root of 8, and positive because I'm in that fourth quadrant, so x should be positive. And then simplifying this radical, I get 2 square roots of 2. So this would equal 2 square roots of 2 over 3. So I can say that cosine of sine inverse of -1/3 is equal to 2 square roots of 2 over 3. Next, I have tangent of cosine inverse. So now here, cosine inverse of a negative number refers to an angle in the second quadrant. Because if cosine of theta is equal to -1/3, like that statement says for inverse functions, I would either be in the second or the third quadrant because x has to be negative. And since I know cosine inverse has a range of 0 to pi, I want to pick that function that's about -1/3 for x. And now, when I draw this triangle, I'm not going to put this big obtuse angle. I'm going to use a reference angle with the x-axis here. So when I draw this triangle, I'm going to point off into the second quadrant, put my x-axis down, and draw my triangle. And I'm going to use that reference angle. Now here, I know that it's adjacent over hypotenuse, so x is negative, but the hypotenuse will be positive. And I can also use Pythagorean theorem to find the remaining side, so I can figure out what tangents of theta is equal to. So -1 squared plus b squared is equal to 3 squared. Using Pythagorean theorem, and I'm going to get a very similar value as I did last time. So b is equal to 2 square roots of 2. And tangent would be opposite over adjacent. So 2 square roots of 2 over -1. So which would just be -2 square roots of 2. So I can say the statement tangent of cosine inverse of -1/3 is equal to -2 square roots of 2. Now lastly, I want to talk about a situation, because so far I've put the inverse function always on the inside. What if it's on the outside, you have a non-inverse function on the inside? Well, the way you would handle this is you would just evaluate that expression on the inside of the function. Meaning, what is cosine of -7 pi over 6? Well, first I could get rid of that negative because I know cosine's an even function. So now I have cosine of just 7 pi over 6, which lies up in the third quadrant about right here, which I know to be -square root 3 over 2. So now I have sine inverse of -square root 3 over 2. Now I'm looking, okay, where is sine -square root 3 over 2? Well, that would happen in the fourth quadrant or the third, but I'm going to use the fourth because I know it's the range of sine inverse. It happens at -pi over 3. And that is how you find the exact value of expressions involving trigonometric functions.